Hello. Welcome to the stream. Today is day 14 and we'll continue on the text editor. Hello, just a second, I'll be back. Okay. Okay, we are back. So, yesterday, what did we do? Let's take a look at we added cross term usage queue. So, we did assignment 2 of this tutorial. Now, today we'll continue by reading Reading helps. Reading actually helps. If I also make notes while whatever I am reading, it'll be good, right? Because I forgot many things. But yeah, it's alright. Okay, I'll revisit them. We'll revisit the whole project at the end and capture all of the juice in one page document. Okay, so we did assignment 2 yesterday. Now we'll move on to the unexpected obstacles. Okay, crossterm uses escape sequences to tell the terminal to hide and show the cursor. The H and L commands are used to turn on and off various terminal features or modes. It appears the cursor hiding showing feature appeared in the later VT models. What is VT? Video terminal programmer information. It was one of the first terminals to support ANSI. Okay. So some terminals might not support hiding showing the cursor, but if they don't, then they will just ignore those escape sequences, which isn't a big deal. Either way, we trust crossterm to use the correct escape sequences for us anyways. Okay. The K command erases part of the current line. Its argument is analogous to the J command's argument. Erases the whole line, erases the part of the line to the left of the cursor, and erases the part of the line to the right of the cursor. 0 is the default argument, and since that's what we want, that's what crossterm uses under the hood. This assignment and the bonus contain 2 unexpected gotchas. Let's first understand the problems together. The first gotcha is we are somehow not allowed to use flush without importing something we don't even need. Okay, let's see, what does it mean? What do they mean by that? So we are importing flush in terminal, right? No, we are importing std out, right? Yeah. And we are doing std out dot flush. Correct. Yes, in execute, correct. Okay. So if we do not include right here, it won't work. That's what they're trying to say. Yeah. Trait right, which provides flush, is implemented but not in scope. Perhaps you want to import it. No method named flush found for struct std out in the current scope items from traits can only be used if the trait is in scope. Okay. So yeah, we'll import right. What is the reasoning behind this? The first, okay, see this code on Rust Playground. Yep, okay. The second issue is that we can't freely pass around our new structs without the compiler complaining at some point. Here is the issue in isolation. So we have a size height. The height is this. Size height equals size. If height is less than 5, it's small, it's tall. What? Used of moved value size. Let size equals get size. Move occurs because size has type size, which does not implement the copy trait. The get size function returns an instance of size with height 2. Hello Nirajan Dhakal. How are you, my friend? Okay. Does not implement the copy trait. What does it mean? To fix this, you can either change the parameter of the two functions, or you can do something cryptic like I did in my code. I'm going to give you a cryptic explanation for both of these things now, then I will explain a couple of things. Then I will repeat the explanation. It should then be less cryptic. Both issues relate to traits. We need to import another trait for stdout so that we can access flush. Move, semantics, and ownership. Pop quiz. What is the result of the following? So we have a struct hecto which doesn't have any parameters. Then we have a function main. We are creating an instance of the struct named as x, and then we are trying to print it. This would print out x is hecto. Does this denote like the type? Let's ask ChatGPT. What does this denote in Rust? What? Let y equals x. X is this and y is this. Let's try to run. Let's comment this out. Let's also comment this one out. X is hecto. Okay. What if I had a parameter in the struct, and then if I try to print this, or it will give me an error. A is 5, 3, run. Source 4. What? Hecto has a derived implementation for the trait debug, but this is intentionally ignored during dead code. Let's see. Hecto cannot be formatted using this. Okay. Okay. The answer is nothing. It doesn't work. Seems weird. Then what about another pop quiz? What is the result of the following? I put an apple in your left hand. You bite into the apple. I take this apple and move it to your right hand. You bite into the apple in your left hand. Then you bite into the apple in your right hand. The answer is nothing. It doesn't work. Let's learn. Rust tries very, very hard to ensure memory safety. Let's take a look at the following metaphor. If you are a proud owner of a lot of money, it's not always practical to carry this around, as it is heavy. You put it somewhere and take a map or multiple maps pointing to different parts of your wealth with you. Those maps represent your wealth. If you are the proud owner of a huge data structure, a file, it's not always practical to move this file around in memory, as it is heavy. You put it somewhere and take a pointer to it with you. We call this dereferencing. That pointer represents your file. If you hand out one of your maps to me and I can then not only access the money you have hidden there, but also the money you have hidden somewhere else, then suddenly one of your maps which you thought points to money points to an IOU by me instead. Similarly, if you copy your map and hand one of them to me and one to your friend, then I take out the money, your friend will find an IOU where they expected money. Your hiding places aren't safe. If you hand one of the pointers to your file to me, then I can then delete some other file of yours, and then suddenly some of your other pointers point to something else. Similarly, if you hand a pointer to me and basically you cannot have two pointers pointing to the same thing as a like a right kind of access. This is what he's trying to say. Different programming languages use different approaches to solve this. C doesn't solve this at all and leaves it to you. The developer JavaScript YOLOs it. Let's learn a few aspects of how Rust does it. Rust is very strict in keeping track about who does what with each value. What we have seen above is the move semantics. Rust moves the ownership of over the struct instance from X to Y. Attempting to access via X is then no longer possible. Why doesn't Rust just copy the value so that X and Y are separate? Rust does that when it can. Try the above examples not with the struct but with integers for X and Y, and you will see that it works perfectly fine. But for more complex data types such as a struct, Rust doesn't really know how to do it because it doesn't have a copy trait. What Rust proposes to us above is that we do not pass the real thing but a pointer to it, or to tell Rust how it can copy the thing. It could guess it itself, as we will see in a bit. Let's fully understand the concept of traits first. Okay, what are traits? We are now confronted with the situation that in order to achieve something, in this case copying something around, we need to implement something. Okay. We have seen this here and there already. Consider this line in the example above. This only works if Rust knows how to create a debug representation of X. Rust knows how to do that for easy data types like unsigned integer 16, but not for structs. So Rust needs a way to tell us, hey, in order to print this as a debug thing, I want you to tell me how, and we need a way to tell Rust this is how you do it. What we are looking for are called traits. A trait is just that, a statement that says you need to implement a couple of things for this to work. Let's code a bit to explore this in depth. Let's say we want our new and shiny test struct hecto to show up as a debug string. Let's try this. We have a struct hecto and print this. This does not compile. Yep. As we saw in here, right? We can run it again. Hecto doesn't implement debug, so that's why we cannot print it. Yep. The trait is not implemented means something like we have to code something so that this works. The docs tell us what this trait looks like. Okay. Debug is a trait. Debug should format the output in a programmer-facing debugging context. Generally speaking, you should just derive a debug implementation when used with the alternate format specifier. Is pretty printed. For more information on formatter, see the module level documentation. Okay. So the debug something looks like there's a function called format. It takes in self and a formatter which is mutable. and returns a result, either an OK or an error. If you try to be smart above and change the print statement a bit, then this would also fail this time, because Rust wants you to implement the display rate. According to the docs, this looks like this. It's kind of the same. So that's basically the exact same function signature. This implies that we can't simply implement that function. We have to do it in a way so that Rust understands which functions implements which trait, so that the actual debug and display representations differ. Fine, we'll do that then. But we are going to be childish about it, and I'll cheat a bit and jump to the solution on how to handle the formatter. Since the point here is not how the formatter works, but how do we tell Rust that we want to implement this method. The answer is that we are implementing the function in a special impl block, which looks like this: impl debug for hecto. This means this implementation block implements the debug trait for the data type hecto. So does that mean that if there are many traits, then each struct should have its own file, because that will like bloat other files? Maybe. So in here we are importing debug, result and formatter, and then we are implementing the debug trait for hecto, and then we write the function signature and then write hecto is awesome. What we do here is to say whatever hecto is, whatever it contains, the only debug information you'll ever need is hecto is awesome. And sure enough, this time the code compiles and the debug info is exactly what we implemented. Try to play around with this and implement the display rate so that this line works. Okay. So we have this display for hecto, right? And then we need the formed function, which takes in a self and takes in a formatter, right? Okay. It returns a result. And then what are we doing here? We will just do a write, and then we'll say that hecto is good, right? F. What is F? F is the formatter. Okay. Formatter of type which. What is this syntax, bro? What is this? A quote underscore. What the heck? Then this should just okay. And the display trait is actually just this run, right? Is it not debug? Run. Display not found in scope. So it is under sp font. Okay. Use std font display, right? And formatter. a struct with a similar name, hecto. What? Hecto. Expected two generic arguments. Implement debug for hecto. Implement display for hecto. Expected std found error, found std io error. Sorry, I am a dumb ass. So error should be here. Run. Implicitly returns this as its body, has no tail or return expression. What is happening, brother? Now if I don't specify these, will it work? What? Yeah. Okay. Okay, expected two arguments. Run. Yep. Okay. We are getting closer to understanding both problems from above now. stdout does not directly implement flush. Instead, it implements a trait called write. What? And that trait requires flush. The reason is that at certain points in the code, we might not want to say we expect a std out here. We might want to say we don't care what this is here as long as it implements the right trait. Bro. So stdout.flush, right? stdout does not directly implement flush. Instead, it implements a trait called write. Okay. And that trait requires flush. Okay. So why don't we do write? The reason is at that certain point we might not want to say we expect an std out here. We might want to say we don't care what this is here as long as it implements the right trait. Implicitly, this is what println does. It doesn't say I want to get a hecto here. it doesn't know this thing. So instead it says I want to have something here that implements debug. The code line this brings the trait in scope and its implementation and makes flush available to us. Okay, so std out implements a trait called write, and since we haven't imported it yet, and that write trait has flush in it, right? So you please, okay. Makes sense. You could easily write your own implementation for write, including your own way to flush, and use this here instead. Okay. That's one thing explained now, but what about the other one? I told you further up that Rust can guess some traits for us, but we have to explicitly tell it to do so, to avoid auto-implementing all kinds of traits we'd never use. That's what derive does. Okay. If instead of implementing the debug trait for Hector, we derived it, our previous code sample would look something like this. Okay. We can also ask Rust to derive the traits necessary for copying things around for us. Copy and clone. So what does this derive mean? That's not terribly important right now, but since you ask, copy is meant to be inexpensive, implicit and quick. You can't implement that one yourself. Rust needs to do it for you. Clone can be heavyweight and you can implement it on your own. Okay. What does this mean? What does derive mean? It is a macro that automatically implements the debug trait. This allows instances of the struct or enum to be formatted using this and this, and similar macros which are useful for debugging purposes. This is an attribute that tells the Rust compiler to automatically generate an implementation of the debug trait for the type it is applied to. Debug trait, a trait provided by the Rust standard library that allows for formatting a value using this. It is typically used for debugging and inspecting the internal state of a value. Okay. So how does it do that? How does it automatically generate? When you annotate this, you are instructing the Rust compiler to generate this macro expansion. The code generated by the derive macro provides a formed method which is required by the debug. This implementation. Okay, so if we have a person f.debug struct. Bro, like what the heck? Debug struct method of the formatter to create a structured debug adds each field calls the finish. Okay. So the debug implementation is automatic if you just do this, right? Even with copy, but clone, since it can be expensive, so we are given the freedom to implement it on our own. Makes sense. Summarizing the assignment. With this knowledge, let's circle back to the two questions that we asked ourselves during the code review. Why do we need to import write though we don't use it? Why did my code have to use something like derive? I'll repeat my answer here. It should be less scripting now. Yep. Both issues relate to traits. We need to import another trait for std out so that we can access flush. And I was telling to create the implementation for, and I was telling Rust to create. Okay. Perhaps it's time to display a welcome message. Let's display the name of our editor and a version number, a third of the way down the screen, centered in the middle of the terminal. So we have a main. Hold on 1 second. Okay, we have a main function, let division equals 9 by 3, debug division, debug longer slicing and this. Okay. Oh, okay. We need to display a welcome message. Note that the data type returned by len is not an unsigned 16. You have to use as to cast it. Okay. The data type for the result is usize. This one is a bit special as its size depends on your system. If your system is 32-bit, usize is 32-bit. If your system is 64, usize is 64. Same applies to the signed counterpart isize. Here is the assignment. A third down the screen and center display hecto and a version number. Bonus refactoring. Use the newfound knowledge around traits to further simplify the code in terminal.rs. Okay. Okay, let's play around with this code. Okay, function main let division is 9.3. Let's try it now. So in editor.rs, instead of position size terminal, same thing, const name is cargo package name and cargo package version. This is how we can access information from the cargo.toml file. Let's not discuss ampersand str right now. This is a bigger topic we need to address later. These consts tell Rust that these values never change. So Rust can optimize them, and the fact that they are all caps tell the same to other developers. cursor to, just added a space here, and then draw welcome message. Let mute welcome message equals format name editor version. Let mute tells the compiler that we intend to mutate our new variable. As we have seen earlier, Rust is very strict and with how it passes around read-only variables. Passing around mutable variables is even harder. We'll encounter this later. Let width equals terminal size width as usize. Let len equals, okay, padding equals width minus len by 2. Okay, how do we center horizontally? We add spaces to the left. Okay, we omit another space here since we want to add this as well. Let spaces this dot repeat, padding minus 1. That's what we want to do. Welcome message. Okay, and then how do we print? Truncate width. What if our welcome message is too long? Let's be on the safe side and truncate the output to be at most as wide as the screen. Okay, let's size height this terminal size. Draw rows. Just added this spaces here if current row is equals height by 3. If current row is height by self draw value. Oh, so when we are drawing tildes on the start of each line, and then when we reach 1/3 of the way, we print the welcome message. To vertically center makes sense. Okay, self q command. And then what is q command? This is one way of requesting that whatever is passed to this method should implement the display trait. We need this because format, which we use elsewhere, does not return a string. As hinted at above, let's shelf that discussion for not much later. It's an important one to have. Is there a reason to prefer the generic syntax over the following? Genuinely asking, not trying to suggest a switch. So the context of this commit is an assignment where people should try and find a way to indicate that they want a parameter that implements a specific trait. My assumption is that people find the notation you used more easily, so I wanted to use the more generic as a additional way. And then q command is just the command trait, which is okay. Q std out and command. This command can be like print, pop probably, move to clear, yeah, whatever. Good. Yeah, let's make these changes. So in editor we need two things: const name and we need an env environment of cargo package name, and then const version, which is also a type of string, and the cargo package version. Move cursor to So here we need a new function which will be responsible for printing the welcome message. Returns a type of result which can be OK or error. Let mute welcome message equals format okay. Okay. Yep. What the hell? This is our welcome message to till these. What the hell? Nothing else. Bro, this is garbage. Okay, let me run this in a proper terminal. Yeah, same shit. What happened? Hector tutorial. Okay. Okay. Then something is definitely wrong. Yes, yeah, that is Ubuntu on Windows. And I'm running NeoVim. Okay. Rust is kind of hard, man. I need to debug a bunch of shit. Okay, let's carry on. So, okay, in this okay. So in draw welcome message, we are formatted here, then width is terminal size width, len welcome message. Let's take a look at what is terminal.print. Print string. Okay. Have I not changed here? You know what? I'll debug this tomorrow. I am too tired to do this shit, man. I'll calculate diff and check what is the difference and what's wrong with my code. So yeah. So that's all for today. We learned, what did we learn today? Yeah, we read a bunch of code. We understood what are traits, why do we implement traits, what is the use of traits, and more stuff like that. So overall it was a good day, and yes, I'll see you tomorrow with the same text editor in Rust shit. Let's go. All right. Yep. Okay, if anyone is here, thanks for being around, and yeah, I'll be here tomorrow again, probably same time, but yeah, it varies. All right, see you guys. Thank you.